Hi guys, it's me again, Angie, and welcome to another video. So for today's video, I'm going to present you the summary of chapter 5 entitled Ethernet. So before it, I'm going to open my NetAcad. So I will launch first. Then chapter 5 Ethernet. For the introduction, the OSI physical layer provides the means to transport the bits that make up a data link layer frame across the network media. Ethernet is now the predominant LAN technology in the world. Ethernet operates in the data link layer and the physical layer. The Ethernet protocol standards define many aspects of network communication, including frame format, frame size, timing, and encoding. When messages are sent between hosts on an Ethernet network, the host format the messages into the frame layout that is specified by the standards. Because Ethernet is comprised of standards at these lower layers, it may best be understood in reference to the OSI model. The OSI model separates the data link layer functionalities of addressing, framing, and accessing the media from the physical layer standards of the media. Ethernet standards define both the layer 2 protocols and the layer 1 technologies. Although Ethernet specifications support different media, bandwidths, and other layer 1 and 2 variations, the basic frame format and address scheme is the same for all varieties of Ethernet. So, for this chapter examines the characteristics and operation of Ethernet as it has evolved from a data from a shared media, contention-based data communications technology to today's high bandwidth full duplex technology. So I'm going to present you my PowerPoint. Chapter 5 Ethernet. So this chapter began with a look at IP addressing basics. This included an overview of the binary decimal conversion process, It continued with an introduction to classful IP addressing, where we outlined how the five classes of addresses are identified, and the number of hosts that each address range supports. The number of available Class A, B, and C networks were also calculated. So, an overview of IP addressing rules outlined the 8 key rules with respect to host addressing, such as the rule that mandates that the host portion of an address cannot be set to all binary zeros or all binary ones. So, the concept and purpose of a subnet mask was introduced, including its relationship to IP address, in defining the split between the network and host portion of an address, default subnet mask values, and when they are used were also examined. So, a look at private IP addressing provided insight into the flexibility that using these addresses provides to organizations, as well as their purpose in helping to avoid the exhaustion of the current IPv4 address space. So, the special subnet mask associated with the three private ranges were also examined, along with the ranges of addresses that each supports. Next, we look at defining the ranges of addresses that were valid on a given subnet, including the processes for determining the beginning and the end of the range. An overview of subnetting provided insight into reasons for deciding to subnet a network. It continued by determining the subnet and host per subnet requirements that should be determined when characterizing a network. The process for determining custom subnet mask was covered in detail, including an overview of how bits are stolen, calculating the number of subnets and hosts per subnet available based on a given mask value was also looked at. The process of determining whether hosts are local or remote to one another was looked at next. We learned that the ANDing process provides a way to not only determine whether hosts are local or remote, but also to find the network ID associated with a given IP address. So, and lastly, a look at classless addressing provided insight into how addressing are now more commonly looked at in this manner rather than by class. An overview of CIDR provided insight for supernetting, address aggregation, and slash notation. So that is all for today. Thank you for watching and see you on my next video. Thank you.